There are two main types of annuities that we're going to discuss. The first being ordinary annuities. So, annuities that are ordinary. What does this mean? Well, annuities in general just means a series of payments over a period of time. And an ordinary annuity is an annuity where the payments are made at the end of the periods. So I'll say payments made at end of the periods. So for example, if you're getting a payment every month and it comes at the end of the month, then that would be an ordinary annuity. And we have a couple equations to represent these scenarios. One equation is FV, or the future value, is equal to C times 1 plus I to the exponent n minus 1 divided by I. So let's just take a breather here and let's talk about what each of these things means. So the future value is the value of these payments being made in the future after they've had a chance to accumulate interest over time, right? C, this here, is the actual amount of each payment, right? So that's the, you could say, payment amount. I, which we see here and also up here, is the interest rate. And N is the number of payments. So we could do an example. Let's say you want to save up for a new car, and your plan is to save $700 at the end of each year. So you want to save $700 at the end of each year, and you want to buy this car before you're finished high school. So you're going to do this for 4 years. Okay? So for 4 years, you're going to put away $700 at the end of each year. Now you would think that after 4 years have passed, that the amount of money you've saved is just 700 times 4, right? So $2,800. But that's not true, because if you can put this money away, you can put it into a savings account that generates interest or some sort of investment, right? And the money is actually going to grow. This is what people mean when they say let your money work for you. Save money and it can grow on its own, right? So let's say you have an investment that you can put this money into that grows money at a rate of 2% per year. Okay? So if we know this, we can figure out what the future value of this investment is going to be, right? We just use that equation. So we'll say the future value is equal to, well, the payment amount, which is $700, times 1 plus I being the interest rate, which is 2%, so I say 1 plus 0.02, we have to write that as a decimal, to the exponent of n being the number of payments. How many payments do we have? Well, we have 4 payments, because we're making these payments at the end of each of these 4 years. So there's 4 payments, minus 1, divided by 0.02. Then you can go ahead and calculate this. And what you're going to get is $2,885.13 approximately, right? So we said before that after 4 payments of $700, you'd think you would save $2,800, but actually if you invest it at 2% a year, that's going to grow to $2,885.13. So you can maximize how much money you're saving if you choose to invest it, right? And this is going to tell you how much money is in the account after those 4 years are up. Okay, let's do another one. So that was for the future value, right? But we also have an equation which calculates the present value of an ordinary annuity. So let's look at this equation. This is C times 1 minus, and you might see this written in one of a couple ways. One way looks like this, where you have 1 plus I to the n, and then this is all divided by I. The other way you might see this written is 1 minus and then 1 plus I to the negative n, because if you flip this fraction, that exponent just becomes negative. So you might see it written that way as well. It means the same thing. Okay? Now, in what situation would I want to find the present value of an ordinary annuity? Well, let's say we're talking about, receiving retirement plan payments or something like that, right? So every month, we'll say, at the end of each month, you could be getting a payment of something like, I don't know, $600, we'll say. So let's say you receive a payment of $600 each month, right? And that's going to go on, we'll just say for 1 year, just to keep it simple. So you're receiving payments of $600 a month for 1 year. Now this money isn't just being given to you for free, right? What's happened is you've saved money in an account, you've gone and you've stashed some money into a savings account, and that account at the end of each month is giving you $600. Now you might just say, well, if it's my money, why don't I just pay myself $600 at the end of each month? Well, because if you think of what $600 a month for a year is, that's 600 times 12. If you do 600 times 12, that's $7,200, right? 600 times 12 is $7,200. Well, you don't actually have $7,200 that you've put into this account. Instead, you've put in less money, but because it's in this account, it's accumulating interest, right? It's growing as it's giving you money. So you might have only had to put $6,500 or $7,000 or something like that into the account, and instead it ends up paying you the equivalent of $7,200. That's why we're figuring out what the present value is. So we could figure out the amount you'd have to put away in the account for it to pay you $600 a month for 12 months, which is $7,200 in cash. So it's going to be less than $7,200, right? Because again, this is a situation that's supposed to be profitable for you. So let's figure it out, right? We need a little bit more information though. One thing that we need that we don't have yet is the interest rate of the account. Let's say that the interest rate is 5% per year, and it's going to be compounded monthly. Okay, so 5% a year, and it's compounded monthly. So let's figure this out. Well, your present value is going to equal the cash flow or the payment itself, so $600 times 1 minus 1 over 1 plus I. But remember, your interest rate is 5%, but it's compounded monthly, right? So it's actually 0.05 out of 12, right, divided by 12. And that's going to be the exponent n. Well, it's over 1 year, but it's 12 months, right? So this is 12, just like that. We're going to divide this all by I, which is 0.05, again, divided by 12. Just like this. So we can calculate this now. And the answer we get is $7,008.73. Now let's see if this answer makes sense to us, right? So you put in $7,008, and once you have received all your payments, those payments are equivalent to $7,200, right? So you put in $7,000 to get $7,200 because this amount here grew over time as it was making these payments to you. So let's say you wanted $600 a month for a year. You don't have to save $7,200. You just save $7,000, put it away in your account, and it will make these payments to you of $600 for each month. Okay, let's do another example. So actually those were ordinary annuities. Now let's talk about the other type of annuity that I was alluding to earlier. This is called Annuities Due. And the only difference between the ordinary annuity and the annuity due is that the annuities due describes a situation in which payments are made at the beginning of the periods. So payments made at the beginning of the period. Okay? So we have different equations for these ones. So the future value of an annuity due is equal to C, 1 plus I to the exponent n minus 1 over I times 1 plus I. That 1 plus I on the n accounts for the extra month in the beginning because you're growing this for an extra month compared to the ordinary annuity because the payment's made at the beginning of the month versus at the end of the month, or I shouldn't say month, whatever the period is, right? So if we want to do an example of this, let's try to make up a scenario. Let's say you have a tenant, right? You could be a landlord in this situation, and they pay you the rent at the beginning of each month, right? We'll say the first of the month they pay you rent. So let's say you want to find the future value over the course of a year of those rent payments that they're making to you, right? And let's assume you're not using this money to spend on a mortgage or anything. Let's say you already own the property, right? So let's say rent is equal to $800, right, per month. That might be low relative to where you live, but we'll just take that as it is. And let's just say you're able to invest this money in a savings account that has an interest rate of 4% per year, and that's going to be compounded monthly, right? So the question is, what's the future value at the end of the first year? So after 1 year of this person paying you rent at $800 a month, how much money do you have? Well, you might be tempted to say, well, it's just $800 times 12, right? Well, what is that? If you do $800 times 12, that's equal to $9,600. So you'd expect more than this, right? Because if they just gave you $800 12 times, you'd have $9,600. But really, what's going on here is they give you $800, and then that first $800 is growing for the year, and then they pay you another $800, and that $800 is growing for the remaining 11 months, and then that continues. So really, you're growing that money, so you expect it to be more than $9,600, right? Okay, so let's calculate this. Future value is equal to C, which is $800 a month, times 1 plus the interest rate, which is 0.04, that's it as a decimal, divided by 12 because it's compounded monthly, to the exponent of 12 because there are 12 payments being made, minus 1, divided by 0.04 over 12, times 1 plus I, so 1 plus 0.04 over 12. Now we can calculate this and see what we get, and remember, you're expecting a value bigger than 9,600. And if you calculate this, you're going to get $9,810.56, and indeed, that is above $9,600, right? It is more than that. So this answer makes sense. Let's look at the final equation. This describes the present value of an annuity due, and this is C times 1 minus 1 over 1 plus I to the exponent n divided by I times 1 plus I, just like that. So again, very, very similar to the present value formula for an ordinary annuity. You have this extra term on the end because we have to account for that extra month in the beginning, right? Because remember, ordinary annuity, nothing's happening in the first month because the first payment's not made till the end of the first month or the first period. That's why we have this term. Now, let's think of an example for this. Let's say you want to set up an account, and this account is going to make payments every month for your phone bill, for example. And your phone bill every month, your phone bill is equal to, we'll say $60 per month. Okay? $60 a month. And you're only planning on having this phone for, we'll say, 2 years. You want to set up an account that is going to pay these bills for you on your behalf. So you're just going to put a certain amount of money in that account and then forget about it. It's going to make these payments for you. The question is, how much money should you stick in that account so it can pay $60 a month for 2 years, right? And we'll say that that account has an interest rate of 3% per year, and it's compounded monthly. So how much money do we have to stick in this account, right? If you're thinking $60 a month for 2 years, that's $60 times 24 months, right? That's going to be $1,440 if you were just going to pay it all, right? Well, the idea of this is that when you put money in the account, there's interest that the account earns, and therefore it's going to grow. So you don't need to invest this much. You can invest a little bit less, and the interest will take care of the difference, right? That's the idea. So if we calculate this, we're going to expect an answer less than $1,440. So the present value is equal to C, which is $60 a month, times 1 minus 1 over 1 plus I is 3%, so 0.03, compounded monthly, so I'm going to say that's divided by 12, to the exponent of 24, because we're doing this over 24 months, right? Divided by I, so divided by 0.03 over 12, multiplied by 1 plus I. I again is 0.03 over 12. Okay? Let's calculate this now. If you calculate this, you're going to get an answer of $1,399.45. So it is slightly less than $1,440. So that's an answer that you would expect to get. So you put this amount into a savings account, and it will successfully make payments each month for 2 years, which equate $1,440. So you're not having to pay the full amount that you would otherwise if you were just paying, once a month, $60. You pay a little bit less because that account is earning interest for you. Okay, and that's it.